first year, second year. Ito, dash 3, no? So if it happened, of course, I'll be delivering the task schedule for most students. Kasi you are 47 and this is around parang 16 lang. So you have 30 students to participate. Okay, so don't worry, wala naman tayong synchronous activity, meaning wala namang sit work today. Assignment lang, so you can just still comply. No? Okay, so, and part of you to balance it out, no? Yung inyong extracurricular activities and of course your study. Okay, so if you will be participating, you're excused, by the way. No? So, okay, let's go straight sa ating discussion for today. So, by the way, I can recall na tayo ay nag-discuss na last time ng syllabus. Can I have a confirmation, class? Anyone? Can I have a confirmation?
Sir.
Okay, so basically, class, ang topic for the prelim is all about stresses. So, ano ba yung stresses? So, let's have first an introduction. Class, are you seeing my presentation here already in Paintam? Class, can I have confirmation? Anyone, can I have confirmation? Are you seeing this presentation in Paintam
Yes,
already?
Po, sir.
Yes po.
Okay, so now for an introduction, no? So last semester you have the course statics of rigid bodies. So meaning we assume, no, based on the given forces or external loading applied to the body, we are assuming that the body will be rigid, or meaning it will not undergo deformation regardless on the support condition. No? So when we say support condition, di ba, let's say for a truss, meron yan. It could be a roller, a hinge, or any pin-connected support. Di ba? And then magkakaroon yun ng reaction. Okay, and then later on, di ba, if you can recall, we compute for the forces acting on the member, which are internal to the member, right? For a truss, we do the methods of section, no? Para makita natin yung makapagawa tayo ng free body diagram, ma-represent natin yung internal forces. Now, as on the static of rigid bodies, again, we assume it to be rigid, meaning walang deformation. So for this figure, no, on this left, okay, these points A, B, and C, meaning kung rigid yung body, it will not deform, hindi magbabago yung location ng point na yan in this certain body. Now, when we are to refer to deformable body, let's say this is a portion of a certain, actually, ito na yung body natin. Let's say yan ay, halimbawa na lang, bato yan, no? Or any material. No? Let's say, magbigay na tayo ng material na parang, let's say, ito ay foam. No? Okay? This is a block of foam. Now, if we will be applying pressure and or forces here externally, then what will happen? Now, these points A, B, C here, initially, no, kung ay deformable, or we assume the body to deform, then points A, B, C will what? Will move, no, will translate in different position. Okay? Now, in our study of mechanics of deformable bodies, no, we are what? We are to deal with those effects of externally applied forces to the body, which will be resulting to what? No? Ano mangyayari? Imagine if we will be applying forces here. Okay? Ano yung response ng body from the externally applied load? No? Ang response niya is that it will develop, number one, internal forces slash load. So on our reference task, di ba, when we do the methods of section, makikita niyo yung axial force acting at the member. Diba? Yun yung isang example ng internal forces. And how about the external forces? No? Of course, given naman na yung mga loading, no, or forces applied to a body are external. And of course, depending on the support condition, no, let's say a roller and the pin, and then magkakaroon pa rin ng reaction yan. No? And still, that will be what? External force applied to the body. Okay? Now, for the deformation on the body, no, as our figure kanina, no, it will produce what? It will produce strain, no, meaning the ratio on the deformation with a given dimension, let's say a length, no? Ayun yung effect na. Okay? Now, plus we will be dealing with strain, no? Relating to stresses on around mid-term. No? So, I'll leave it here. No? But again, the deformation on the body is internal to the body. Okay? So, paano ba natin, di ba, how do we do na-analyze natin yung certain body or structure na makikita natin yung mga effect ng externally applied load. So, as an example here, class, refer to this beam. No, it is simply supported with hinge or pin here, no, and a roller on the right, no, at point B. Now, class, if it is loaded, no, with different types of loading or externally applied forces, for example, meron tayong concentrated load of force F here, then meron tayong bending moment here applied at this point, then meron din tayong torsional moment which will be discussed na meron tayong separate topic dyan. So imagine kasi ito yung beam na yun. No? This is the externally applied forces. No? Ito yung concentrated load. Then this is the bending moment. No? When you say bending moment, it bends the member. Now, when we say torsional moment represented by M sub T here, no? It is the twisting moment. No? On a certain bar or body, no, or structure. Now, if we are to analyze, no, the effect of this externally applied load on this structure, ano mangyayari? Siyempre may support condition yan. Magkakaroon ng reaction here, no, RA and RB. Okay, and still that would be what? External to this particular body or member here, the beam. Now, if we want to know, no, or represent the internal forces acting on the body. Then ano ginagawa natin? Doing by producing here a cutting plane. No? Diba? When we do this cutting plane, actually this is a method of section. No? Ano mangyayari? Refer to this figure below. No? Okay, if you cut that section here, no? What you will be seeing is what? Okay, an axial force here represented by N, no, or a normal force. So we say it normal force or axial force or simply normal force kapag kapag perpendicular yan to the section that we are analyzing. So in this case, let's say this beam has a rectangular section. Now let me zoom this one. Then the normal force is what? Perpendicular to the section being analyzed here. No? So parang imagine nyo na lang class na magbigay tayo ng isang reference. No? Let's say itong braso ko, no? Itong, now I will be pinching or I will exert pressure here. So it represents the externally applied forces here on my hand. No? If we are to check, guys, are you seeing my illustration here, by the way, on my hand?
Yes po.
Okay, so imagine ito yung external forces applied to this. Let's say ito yung body. No? Okay, this is the member. Okay, now if I press this tightly, no, if I want to check, no, the effect of this externally applied load on the internal body, no, I will be what, cutting this one. So imagine na pinutol ko itong kamay ko. Ano mangyayari? Ano makikita mo? Diba? You will see the cutting section here. No? Makikita nyo, pwedeng sumirit yung dugo dyan, may pressure, pwedeng tumagas yung mga, diba, yung laman dyan, and so on and so forth. Meaning, merong effect yung externally applied forces on the internal body, or meaning on the bodies internally. Okay, so in this case, if we are dealing with any type of structure, for example, a beam, no? If we produce a cutting section here or a cutting plane, then you will be seeing what the internal forces effect produced coming from this externally applied load. And as you can see, of course, normal force, no, on the cutted section here, perpendicular to the section, no, and itong B here, no, it represents what? The shear force, no, or a vertical force that is what? Parallel or tangential with the cross-sectional area. Now, how about the moments here and represented by, this is bending moment, no? Then this is torsional moment. Go ahead, what is that? Do you have question? Go ahead. Okay, this is an attendance. Kindly address it, no? I'll be checking it later, no? So, sige, acknowledge. Now, again, no, we're discussing section here, no? With the method of section. Ano makikita nyo dyan? Internally with the member, di ba? Again, bukod sa normal force and the shear force, di ba? Action, reaction, no? Kung may applied bending moment here, then magkakaroon din ng reaction na magkakaroon ng bending moment at the member internally. And also, kung merong torsional moment here, magkakaroon din ng internal forces, no? uh, with this particular cut section, no? To resist or develop dahil nga sa externally applied forces. Okay, so again, the representation here for N is the normal force parallel to the section. Okay, and then or the cross-sectional area being considered, then for the shear force, this is perpendicular or this is parallel, no, to the cross-sectional area. And of course, bending moments that you are familiar already, no? Uh, then ito lang naman yung bago sa inyo, yung torsional moment, which is a twisting moment, no? Or the twisting, yes, twisting moment on any um, body being subjected to. Okay, so again, these are internal forces, and these forces will produce what? Internal stresses to the body. So, guys, imagine nyo na lang, no? Itong cutted plane here. So, imagine class, no? Itong cutted section here, no? Produced by methods of section here, no? Again, this is a free body diagram. Okay? Imagine ito yung cross-section ng kamay ko. And then, this is the normal force, no? Okay? Anong mararamdaman ng kamay ko? Diba? Pag tinusok ko yan, diba? This is a force. Diba? This is the internal force acting to my palm. Ano mangyayari, diba? Ano yan, may stress yan or makakaramdam ng pain. So the pain represents stress. And simply, those force what distributes what stresses all over an area. Okay? So, and of course, for the shear force, let's say this is the two member here na naghiwalay, no? Kitat mo yan. Okay, the shear force, ito ay parang sa Tagalog ay punit or tear, no? It's a tearing force. Okay, represented by B. And again, that will produce internal stresses. Okay, so now how can we solve, no, those unknown parameters? So again, what are the unknown parameters? So let's continue, no? Or let's reiterate again. If there's a body being subjected to an externally applied load, no, let's say for a beam, then what will happen? Depending on the support condition, magkakaroon ng reaction, which is still external to the body, which is the beam. And now, if we are to analyze the effect, no, ng externally applied forces to the body, we have to draw a free body diagram by producing a cutting section here using method of section. Then, ano mangyayari? Makikita nyo here, no? Na-represent na yung mga internal forces or loadings on the body. And the representing here a section, no? Or cross-sectional area of any member or body. Now, how can we solve that unknown parameter? So, anong dito? Unknown yung reaction, di ba? Which can be computed using statics or equations of equilibrium. Now, these other unknown forces here, or unknown parameters, which are internal to the body, it can be also solved using equations of equilibrium. Di ba? Anong meron tayo sa equations of equilibrium? That would be summation forces vertical, summation forces horizontal, and summation moment. Now, if it happened na mas madami yung unknown parameters compared to the available equation, we simply call it what? Statically indeterminate structure. Now, in most cases on our study in statics of rigid bodies rather, the structure are statically determinate, meaning the available equations, applying equations of equilibrium, is equal to the number of the unknowns. No? So it could be reaction, it could be a member on the truss. No? Parehas, kaya solvable or meaning determinate. Now, kung sakali namang hindi na mas madami na yung unknown parameters, it will be statically indeterminate. So meaning hindi available, hindi na sapat itong equations of equilibrium. Here comes the help, no, in our study in mechanics of deformable bodies when we are to study deformation. Kasi kung kulang na yung available solution for equations of equilibrium, we have different methods or techniques to compute for unknown parameters um, considering deformation. So meron tayong mga different methods in addition to equations of equilibrium. Okay? So yan yung magiging um, focus here, no, on our study, I think around the midterm. But still, kung kaya naman, kung solvable yan with available equations coming from equilibrium, no, condition, then we can do that. Okay, now this is only an introduction, by the way, so we go jump straight to our official discussion, which is all about simple stress, particularly normal stress. Okay, guys, are you with me with this presentation for normal stress? Class, can I have a confirmation? Okay, so for the normal stress, no, for example nga itong, let's say this is the beam earlier, no, and then we produce a cutting section. Okay? Ang makikita nyo dyan is a normal force and shear force. Okay? Typically, unless meron dyang restriction on the support and merong bending moment. But now for the study of normal stress, no? Under simple stress, no? Again, imagine this cross-sectional area here, no? Is my pulp. So again, if this is applied with an axial force, no? Applied to the center or the centroid of my palm, which represents this area here. No? This force is again perpendicular to this area. And also this is applied, no? This is assumed to be applied at the center or the centroid of my palm or an area in order to produce um, equal stress distribution on my palm. Now, with that, the formula under simple stress, okay, particularly normal stress, is what? Stress is equal to force over area, okay, or meaning it is a ratio of a force over area. Now, what are the type of simple stresses? So once again, itong pinag-uusapan natin, no? Normal stress, take note, the force is normal and axial to this particular body or let's say a member of a structure being subjected to stresses. Okay, now for the shearing stress, okay, the force being considered here is parallel uh, with this area. Okay, and for the bearing stress, we will be tackling this one after shearing stress. But for now, let's focus here muna sa normal stress. We do first unit analysis on stress. Okay, so class, what are your known units of force? No, anyone? Ano mga units of force that you know? Anyone? What are the units of forces that you know? Class, anong mga units of forces? Go ahead.
Newton po.
Okay, what else? In English naman, ano pa ang mga alam nila? English system. What else? Di ba pounds, okay, keeps, and that's the unit of force, di ba? Newton, pounds, keeps. So, 1 keeps is equal to 1,000 pounds. Okay, take note class, itong unit conversion. That's for the unit of a force. And then, we have units of area. No? Siyempre, square meter, millimeter square, and inches square. Yan yung typical naman. Okay? Now, for the units of stresses, diba, again, stress is what? The ratio of a unit force divided by an area being considered, no? For an effect of a stress. No? So, that will be what? Unit force over an area. So, let's say Newton yung unit ng force, that will be Newton per meter squared. And take note, guys, Newton per meter squared represents Pascal here, PA, no? Or Pascal. Now, Newton per millimeter square is megapascal. Okay, and mega class in our on your scientific notation with prefixes, no, m represents what? The symbol represents times 10 raised to 6, di ba? So m here megapascal times 10 raised to 6 pascal. So let's say you have 5 megapascal, then that would be what? 5 times 10 raised to 6 pascal. Okay, so how about in PSI and KSI? So we have here what? Pounds per square inches, no? In case in unit nyo, in English system, for stress. Then kips per square inches represents KSI. So in case may encounter yung mga units na yan for stresses. Okay, so um, let's continue. Now, okay, the important notes to take away here is that um, at- under normal stress, the resisting area is uh, perpendicular to the applied force, or meaning normal. No? So, okay, class, take a look on this figure. Now, let's say this bar is being subjected to two forces on both ends. So, kung makikita niyo yan, di ba, it will produce the bar to be subjected in tension. Okay? Whereas on this, on the right photo here, if it is applied, no? Okay, imagine ito yung ball pen, no? Of course, kung hihilahin ko yan, that will be in tension. Di ba? Yun yung um, on this left figure. Then on the right, no? Kung i-compress ko naman yan, let's say tutulak ko ito pag ano, diba? It will, but this pen will be subjected to compression. Now, I know for sure you are familiar with this one on our analysis of thrust, but okay, now if we will be producing a cutting section here, makikita natin to. No? On this area, magkakaroon din yan ng equivalent force P, no, to react on this externally applied load. If we cut the section here, no, then it will what? It will what? It will have same value of reaction here on P. So take note, action, reaction, no? Equal yan. And if you will be applying equations of equilibrium, summation of force horizontal, di ba? This is going to the left, then of course, this is going to the right with an equivalent magnitude of force. Okay, now take note this force P here is normal to this area being considered, and meaning, no, this body is subjected to normal stress. Okay, and again, the formula is that stress is equal to P all over the area here. No? So let's say, as circle nga yan, di? Ano area ng circle? Pi over 4 d squared. Ano yung value ng P here? So given yan. Okay, so later we will be having an example with this one. Now, class, if you are to consider also, syempre, di ba, as I have told you, no? Depending on the applied force, a certain body will deform. Now, let's say on this bar, nag-apply tayo ng pulling force or tensile force here, both ends. What will happen? No, it could what? This bar could elongate. Now, this represents the deformation here. L represents the original length, and delta here represents the additional uh, length here. No? Produced by this externally applied force. And now, class, once again, if we will produce a cutting section here, no, using methods of section, you will be seeing once again um, the force of section being considered. And again, with this externally applied load here, considering the left portion of a free body diagram, then of course, ang nangyayari, magkakaroon yan internally ng reaction itong member or body. So in this case, it is equivalent to this particular magnitude of P. And again, this P is internal to the body. And stress, and or rather normal stress, is equal to P all over A. Okay, so let's have an example to apply these concepts about normal stress. Okay, so class, are you with me with problem number 1?
Yes po.
Okay, so prepare your calculator. I will be asking your participation. So for problem number 1, a hollow steel tube with an inside diameter of 100 millimeter carry a tensile load of 400 kilonewton. Now determine the outside diameter of the tube if the stress is limited to 120. What is this one? M stands for class. M stands for class. Dilam? M stands for mega, di ba? So this is what? 120 mega Pascal. And 120 megapascal, anong representation ng unit yan? Ng unit per area? Unit force per area? 120 ano? Anyone? 120 Newton per, ano to class ng denominator? Class ng denominator here? 120?
Millimeter squared, sir.
Okay. Anyone can participate class now. There's no incorrect answer. I mean, incorrect participation. No? Okay, so don't be shy to participate. So 120 Newton per millimeter square. So tama siya. Now, okay, so ang kailangan lang natin dito is that dapat yung mga units ay pare-parehas when we do the substitute ng mga formula. Again, anong formula natin for normal stress? Take note, this is the force here actually loaded and the area being considered. Let's say we will be cutting here a section. Then you will see this section ng hollow tube. Okay, and then this area is what? This force is perpendicular to this particular area. Okay? So, anong formula natin for normal stress? Stress is equal to plus stress is equal to ano yung formula?
Force over area po.
Okay, force over area and okay, tama. Then this is P all over area. Now, let's write all the given muna. No? Ano ba yung given dito? Given ay, of course, this tensile force, P, is equal to 400 plus this is kilonewton. No? We need this into Newton kasi nga yung ating stress here, okay, is the allowable stress, no? Okay, is 120 Newton per millimeter square. Now, class, when you see this word limited, no, or the stress limit, it also denotes the allowable stress and also it denotes the working stress. So meaning class, yan lang yung allowed for this material. So ito ay hollow tube. No? Yan yung allowed na maximum stress na dapat maramdaman lang or ma-experience itong particular member na tube, ng body na to. Okay? So kumbaga yun yung limit. Okay? So using that limit, we can already determine, no? Let's say ipapabricate natin tong or ipapa-manufacture natin tong tubo na to. Okay? Or hollow tube. Then we can already provide the specification, no? Kung gaano kalaki yung diameter ng mga tubo or dimension. Okay, so again, let's continue. The given here is tensile force 400 kilonewton. And then, okay, the inside diameter is 100 millimeter. So, let's say, D sub I na lang to is 100 millimeter. And diameter outside, ito yung hinahanap. Okay, and then, the given stress here, no? Okay, the limit, no? The stress is limited to 120 megapascal, which is Newton per millimeter square. And again, this is the allowable stress, okay, or working stress. Now, using the formula here, stress is equal to force over area. First, anong area natin being considered? Di ba hollow yan? Okay? Let me go right here. A little bigger pala. So, kung yan ang area, okay, ano yung affected area lang? Di ba hollow yan? So, meaning butas yan. So, ang area lang being considered here or subjected to a normal stress is what? This shaded region. And as you can see, this is the outside diameter, D sub O. Then, given naman yung D sub I, so, or the inner diameter, drawing na lang natin here. And dimension, this is 100 millimeters. Okay? Now, ano yung formula natin for circle? Di ba? Ang area is what? Area per circle is equal to pi all over 4 p squared. Di ba? So, okay. But also, di ba, kung yan ay kailangan natin yung shaded portion, so meaning yung area nung with the outside diameter minus the area ng inner diameter here will give you the shaded region, no? Or the area of the shaded region. So that will be what? Pi all over 4 times P o squared minus pi all over 4 times d sub I squared. Or simply kung i-extract out natin or i-factor out natin tong pi over 4, that will be what? Pi all over 4 d sub O squared minus d sub I squared. Right? So this is the formula for area. Now we are ready to compute. Diba? So, um, okay, let's substitute the given. So, limiting, the stress is limited to 120 megapascal, or this is only the allowable stress. So that will be the stress is equal to force over area. So that would be stress P all over A. Then that will be 120 Newton per Newton per millimeter square is equal to force P. Anong given natin class for force P? 400.
100.
Ano yung multiplier ko dito para maging Newton? This is in kilonewton. Times 10 raised to, ilan to class? Kilo
3 po.
times 3. Yes, tama. No? So this will be in Newton na. Ito yung prefixes ng kilo, di ba? It can be replaced by a multiplier ng a factor of 10 with an exponent of 3. Okay, so times 10 raised to 3 Newton, that's P. Then the area here, okay, for this hollow section, that would be pi all over 4 times the unknown is d sub O squared minus d sub I is 100 millimeter. No? So naka-millimeter din tayo dito. So walang problem. Parehas tayo ng units. Okay, you can just directly substitute that and square. Right? Now, Newton will cancel. As you can see, naka-square to. Then millimeter, that will give you a value of diameter in millimeter. Okay, this is pi over 4. Now, class, you can just simply what do a direct calculation. No? You can do sheet solve, pero i-simplify ko to. No? I mean, i-arrange this one para makita niyo yung complete solution. Okay, so cross multiply. Okay, kukunin ko, i-separate ko tong unknown, which is d sub O. That will be what? D sub O square minus 100 square is equal to 400 times 10 raised to 3 divided by, of course, naiwan yung pi over 4 dyan, times, of course, 120. Okay. Then, d sub O squared, yun lang matitira natin on the left hand of our equation here. That will be 400 times 10 raised to 3 all over pi all over 4 times 120. And transpose this on the other side of the equation. It will be plus 100 squared. And squaring both sides, that will give you already the value of the unknown diameter here, or the outside diameter of the hollow tube. Guys, can you give me the value of this sub O here? By the way, you can right away do some sheet solve here, no? If you want, no? Using the power of your calculator. Pero, okay, I'm considering this one already a solution in case nasulit na yan. Pero mas madali kasi i-compute. No? Ito dahil naka-square ito. Yung calculus minsan nahihirapan pag meron mga square or cube sa unknown. Kasi hindi na linear yung analysis ng calculus. Okay, so can you give me the value of the diameter here in 2 decimal place? Guys, ano na-compute niya? Go ahead. Ilan? Can you speak? 100? Or can you verify this? 119.35? Same lang? Anyone?
Yes po.
Okay. So, 119.35 millimeter. Now, class, ano yung conclusion dito? Is that kung 120 megapascal yung allowable stress, no? Nitong hollow steel tube. Okay? Meaning, if you are to give this one into manufacturing, no? Ano ang ilalagay mo na diameter or dimension ng mga tubo for publication? So at least, no, dapat hindi yan bababa ng 119.35. So let's say ipapa-manufacture na yan, that should be at least 120 millimeter and more than. Kasi kapag mas lumit yan, no, ano mangyayari? Di ba? The smaller the area, okay, anong nangyayari no, with this equation? Mas lumalaki yung stress. So meaning kung mas lumit yan, no, there's some possibility na this uh, hollow tube will fail kung sakaling lilitan mo yung um, diameter, no, outside. Kasi given na yung 100 millimeter on the inside diameter. Okay? So again, ang takeaway here is that the allowable stress is also the limiting stress or the working stress that we are referring to, no, when we are dealing with the strength of this particular material. Okay? So more of this example for normal stress. That is for problem number 2. Guys, are you with me with problem number 2? Can I have a confirmation? Class, on your screen. Problem number 2 already. Class, can I have confirmation? Go ahead. Can you confirm?
Dito po, sir.
Okay, so this is problem number 2 already. Okay, so let's continue. A homogeneous 800 kilogram bar, AB, ito yun, no, is supported at either end by a cable as shown in figure P-105. Okay, so calculate the smallest area of each cable if the stress is not to exceed 90 megapascal in bronze and 120 megapascal in steel. So again, class, this is the homogeneous bar supported by this cable. No? This is made of bronze, then this is made of steel. And again, yung strength ng bronze and steel ay magkaiba. Okay? Or meaning yung allowable stress, okay, or the limiting stress is limited only to 90 megapascal for the bronze and whereas 120 megapascal for steel. So given din yung mga length na nandyan, okay, ng or dimension, okay. Now, how can we solve for this particular problem? Diba, ang hinahanap dito ay the diameter for this cable to carry, no, enough this bar with a given weight of 800 kilogram and should not exceed its allowable um, stresses which are 90 and 120 megapascal. Meaning kasi pag na-exceed niyan yung allowable stresses niyan, ano mangyayari? Magpipil yan. Pwede yung, anong nangyayari? Mapuputol. No? Or pwede yung unti-unti mo ng, di ba yung cable? If you can imagine. Siyempre may tension yan. Unti-unti yung maglulus muna din until bago siya magpaputol. Okay? So, of course, para makita natin yung internal forces acting on the cable, siyempre we produce what? Cutting plane here, no? Or a cutting section here using methods of section, and we interpret that into a pre-body diagram. Okay, so let's say I will introduce here or I cut this section here. No? Kung kinat ko yan, then, okay, ito na lang sa baba. No? Let's say let's reproduce a horizontal cutting plane here. Okay, and then what you will be seeing are what? The internal forces acting on the member. And then for the cable, di ba? Of course, action-reaction class. This bar AB has a weight of 800 kilogram, so located at the center of bar AB. And then, okay, what are the other forces involved? So when we cut this one, we will be seeing the internal forces acting on the body or the member here, which is cable. And then, of course, on the other hand, if we will be transferring this force, diba? Action, reaction, okay, opposite direction but equal in magnitude. So this particular force or tension here equates also to this tension um, applied on the support. Okay, so now we will be considering only the lower portion of this particular cutting plate. No? So we draw the free body diagram. Okay, that's our free body diagram. Okay, I hope marunong na kayo mag-draw ng free body diagram. So we consider, okay, the lower portion of the cutting plane. So that will be, let's draw the bar here now. Gagawin ko na lang siyang linear. Okay, this is bar AB. Let's say this is point A and B. Then, of course, we have to represent the weight of the bar. That is downward. Siyempre, weight yan. Downward. And then, this is W. Now, class, take note, ang given here is in kilogram. Okay? And we all know that the formula for weight is what? Weight is equal to mass times, okay, the gravitational pull. Okay? Or simply, this is the acceleration due to gravity. And take note, force is equal to mass times acceleration, and weight. A weight is a type of force. Okay? So, compute mo natin, convert natin tong weight. Okay? So, this is 800 kilogram plus anong acceleration due to gravity? Ilan ang value?
9.8 po.
9.81. Okay, ano yung unit? Meter acceleration.
Meter per second squared, sir.
Okay, tama. Now, let's compute this one. This will be 800 times 9.81. That will give you 7848. No? Kilogram meters per second squared. And take note that kilogram meters per second squared represent 1 Newton. Okay, so meaning 7,848 Newton yung weight. So let's write it here. This is 7,848 Newton. Okay, I'll write a note here for your reference. 1 Newton represents 1 kilogram meters per second squared if we are referring to unit analysis. Okay, so now let's complete the free body diagram. That's the weight, of course, acting at the center of this bar AB. And then the cutting plane here, ano pa yung forces? This is the force representing the internal force acting on the cable. Diba? So let's write it here. Then let's say cable, wala naman nakalito na. Let's say, lagay natin tension at cable. Bronze na lang, PB. Represent sa bronze. Then, tension acting at the cable with a material of steel. So, TS na lang. Okay? Now, class, if you are, how can you compute na lang rather, no? With this tension, forces. How can we compute? What equations can we apply? No? In statics, ano yung ating equations available? Equations of gas, equations of anyone?
Equilibrium po.
Okay. Equations of equilibrium, that would be summation of forces or summation moment. Now, as if we will be doing summation of forces, of course, vertical, di ba? We have two unknowns, so we cannot solve directly, no? Yung value ng tension or T sub B or tension at bronze cable and consequently tension at the steel cable. So what we can do is we can do summation moment at a point. No? If we do summation moment at point A, we can solve T sub S. But take note guys, this is actually what nakita nyo, symmetrical yan, no? Yung loading here. So we can just simply assume na itong T sub B and T sub S ay paghahatian niya yung weight. No? Or meaning bubuhatin ng tension sa to equally itong 7,848 Newton weight. But to verify that case, no, para may method tayo, we do we apply the equations of equilibrium. That will be summation moment at point A is equal to, again, equilibrium 0. Assumption natin ng direction ng rotation ng moment is positive clockwise. Now, class, if we were to take a moment about point A, can you give me, of course, I forgot the dimension here, 5 meters. 5 meters. Summation moment about point A. Okay, this weight about point A will rotate about what? Clockwise. So meaning positive or negative? Positive moment
Positive.
or okay, positive moment, 'di ba? Kasi umaayon yan dun sa ating direction ng positive moment assumption which is clockwise. So meaning that will be what? Positive. The moment effect of W is positive. So hindi ko nilalagay. Positive yan. W, no, force times the perpendicular distance or moment arm. Ilan yan plus from point A? Moment about A. Okay,
5.
5 meters. Okay. Now, how about itong T sub S? Okay. Positive or negative? Itong T sub S. Moment about point A.
Negative.
Yes. Tama. Negative, no? So, negative T sub S. What's our moment arm? To point A. This will be what?
10 po.
10. Tama. And now, my question is, ito bang T sub B ay may moment effect about point A? Plus, may moment effect ba itong T sub B about point A?
Wala po.
Wala, di ba? Kasi unang-una, wala naman yung moment arm, no? Coming from point A. So, hindi yan magpo-produce ng rotation. And, um, or hindi yan magpo-produce ng moment. Okay? And also, anything, no, in our in concept, no? Anything that pass through a given moment center, no, any force, will produce no moment effect. Kasi nga, on the first hand, wala yung distance from that point, or it will not, it has, it doesn't have a moment arm, okay, to produce a certain moment or bending moment or rotation. Okay, so let's equate this one to 0, but of course, may value tayo ng weight which is 7848 times 5 minus T sub S times 10 is equal to 0. Now, I will transpose T sub S. Okay, that will be T sub S times 10 is equal to, or let me write it this way, 10 T sub S na lang to, no? Positive na yan is equal to, of course, 7848 times 5. Take note, class, no? Kung i-simplify natin ito, that will be 7848 times 5 out of 10. And take note, this is what? 1/2, right? As you can see, kung symmetrical yung loading, okay, the reactions at point A and B is what? Equal, di ba? Or paghahatian lang, just like what I have said earlier. But to verify the case, applying equations of equilibrium using summation moment, then really, T sub S is 1/2 of 7848. And that will give you 3924. Tama?
Opo.
Okay.
3924.
So 3924, anong unit natin? Newton, right? And thus, kahit i-minus mo yan with 7848, yung summation force ka naman, vertical, that will be T sub B plus T sub S. Sige, kumpituhin natin. Apply, para review na rin. Summation force vertical equals 0, positive going upward, that will be T sub B plus T sub S minus 7848 is equal to 0. And as you can see, T sub B is equal to 7848 minus T sub S, which is 3924. Then that will give you still 3924. Ito. Okay, so you already know the values of the tension acting at the cable. No? So now again, this tension acting at the cable is internal to the body. Okay, so nakita natin yan through the cutting plane introducing this free body diagram. Okay, so now we can already compute for the ano yung dito, smallest area. no, ng cable if given naman dito yung allowable stresses. So, what are the other given? Let me zoom this out a little bit. Okay, so ang allowable stress slash limit. Okay, limit lang. Stress sub, ano lang to, sigma sub, okay, for bronze, sub B na lang to. It's equal to 90 megapascal. Then, sigma sub steel is equal to 120 megapascal. Okay, now for bronze cable, no? Okay, that will be what? Okay, ano pa rin natin dito, Alex? Stress is equal to P all over A. Diba? Then also, cross multiply P is equal to stress times area. No? Okay, so ito na rin pinili natin. Okay, so you can just maybe do linearly sa calculator na sa pag-input. Okay, so P is equal to stress times area. Okay, then the given P is what? Ano yung force? This is the force acting at the cable. So this will be what? This is what? T sub S or T sub B rather na. T sub B is equal to itong stress, allowable stress sa bronze times the given area. Okay? So ito yung A sub B. Ito yung hinahanap, no? Ano yung area required, no? Given these allowable stresses or limiting stresses for the bronze cable. So that will be T sub B is 3924 newtons is equal to 90 megapascal. That will be Newton per millimeter square times area not required for the bronze cable. Okay, can you compute this one, class? Cancel yung Newton. Then A sub B here is equal to 3924 divided by 90. And that will give you a millimeter square unit. Yan to, class. 3924 divided by 90.
43.6 po.
43. Point 6. Sakto? Sakto ba?
Yes, sir.
Okay, so meaning, class, this is only for bronze cable. No? Meaning ang required na area, no, for this cable is at least 43.60 millimeter square kung ang given na allowable stress limit or allowable stress for the bronze is 90 megapascal. Okay, kasi kung mas maliliit ka pa dyan, mag-fail na yung member, meaning mapuputol na yung bronze, given na yan yung weight is 800 kilograms. Okay, so for the for the stress, rather for the steel cable, that will be what? Of course, that will be P is equals to stress times area again, no? And P here represents the force acting at the cable, no? The tension. Then that will be T sub S here. So T sub S is equal to stress sub S here, no? For the steel times the area for the steel. So that will be what? T sub S, equal lang naman yan, no? 3924 pa rin. Newton is equal to this is already 120 for the steel. Newton per millimeter square per megapascal, and then multiplied by the area required for the steel. Okay, so ilan to, class? A sub S is equal to 3924 divided by 120. Okay, this is millimeter square. Ilan question? Anong answer niya, class? Go ahead. Class, go ahead. Ano yung na-complete niya? You can speak.
32.7 po, sir.
Okay, tama na. 32.7 millimeters square. So, meaning for the steel cable, at least ang area should be 32.7 millimeters square in order na makarry itong 800 kilogram weight of bar AB without failure on those particular cables. No? So, ayun yan. Kumbaga somehow you are just already designing here based on the working stresses or allowable stresses no? On the material. Okay? So, sometimes sinasabi na parang strength ng material, no? Pero we indicate that yan na parang allowable stresses or working stresses. Okay? Kumbaga ganun kalakas lang yung kayang dalhin ng cable na yan. Okay, so let's go on problem number 3. Okay, do you have question by the way class for problem number 2? I think that's a very, direct formula naman. You just need to, of course, anong kailangan nyo? You know how to compute, you know how to draw free-body diagram, you know how to compute applying equations of equilibrium, then you just simply use the stress formula P all over A for normal stresses. Okay, to solve for some unknown parameters if you are to compute um, for those type of problems. Okay, so problem number 3. Guys, okay na sa screen ninyo? Hindi siya nag-loading. Okay, nag-loading siya kanina sa akin. Are you with me with problem number 3? Can I have confirmation?
Okay.
Okay, so let's continue. So a homogeneous bar shown in figure P-106. Meaning kasi kung homogeneous yan, equal, if we will be cutting in any section here ng bar, equal yung area niyan and di isa yung material. Okay? When we say homogeneous. Okay? It is supported by a pin at C and a cable that runs from point A to point B around the smooth peg at point D. Now, find the stress in the cable if its diameter is 0.6 inches square and the bar weighs 600 pounds. Now, class, for this problem, let's analyze muna. Okay, the support here is, this is a peg or a pin no, at point C. Then, at this cable D, no, it is also, ano sinabi dito, this is a smooth peg or simply, kumbaga, itong cable na to ay nakapatong lang dito without friction. No? Neglecting friction, kumbaga, nakasupport yan here from point A to point B. Okay, nakapatong yan at point B on this particular smooth peg. Okay, so now, what else? There's a given weight here. No? Kumbaga, wala namang ibang load kundi yung weight lang ng bar. Okay, and again, we can represent the weight of the bar here at the center of the bar. Okay, or at the location of the center. No? And of course, do we need to compute for the reactions of this problem? So before we can solve for the tension acting at the cable, kasi yun yung requirement here. Kailangan natin makompute yung tension acting at the cable in order to compute for the stress that is being experienced by the cable. Kasi given naman yung diameter. Diba? So the stress is equal to P all over area and the force or the P acting at the cable is the tension. No? So kung na-compute natin yung tension, then that's it. Stress is equal to P all over area already. Okay, so let's do that. So if we, again, using methods of section here, produce a cutting section, then let's draw the free body diagram, okay, below. So again, class, kung ito yung tension here, of course, we have to represent an opposing force here for the transfer of this force going to the smooth peg at D. No? So if you will be isolating this one, ito yun yung transfer ng cable, force ng cable na yan, opposite on this direction. Right? So, yeah. Okay, so we considered itong bottom part ng cutting section as our free body diagram. So that will be FED. Okay, ilagay ko na lang na FPD class na. Or pre-body diagram. Kung halimbawa may cutting section yan nakalagay, let's say ang cutting section na nalagay is AA or AA prime. So FBD AA prime. Considering um, bottom section. So that will be bottom section here or below here. So let's draw that. I-simplify ko na lang yung bar na linear. So of course meron yung pin support here. And then point A, point B, at the middle of the bar. And then point C. Of course, ilan yung weight class? Can you recall? Ilan yung weight ng bar na bubuhatin ng tension cable? Can you recall? Bigyan na natin 600 pounds. Okay? So that's 600 pounds of weight for the bar. Rather, 6,000 pounds ata. 6,000. Okay? And then, of course, let's draw the force, now the tension force that represents the internal effect acting at the cable. So that will be T, and also here na at point B, this is also T. Right. Now, what else? What do we need? Now, of course, this is dimension 5 meters. 5 meters. And now, class, if you will be applying already equations of equilibrium, we will be needing what on this force, no? This inclined T. Kailangan natin ng slope triangle. So we can just use the components for this particular tension force. No? So kailangan natin to ng kailangan natin dito rather ng slope triangle. So anong slope triangle natin dito? Can you give me? This is what? Yung vertical component ng slope triangle based on the dimension. Ano to?
3 po.
Okay, how about itong horizontal?
5.
Tama. Okay, this is 5. And then, Katz, can you give me the hypotenuse of this slope triangle? Ilan yan?
Square root of 34.
Okay, very good. Now, of course, class, alam niyo naman na may component yan, no? Ilagay na natin para review na rin, pero dapat yan ay automatic sa inyo, no? Pag nagsulat kayo ng equation. For the purpose na ma-review na rin yung iba. No? Of course, this is the vertical component. No? This is the horizontal, this is the vertical. So, vertical component of inclined T here, that will be what? This is T sub V, lagay na natin T sub V. And for the horizontal, T sub H. Now, class, if you are to represent, no, itong T sub B in terms of the value coming from T, so ano nga ulit yan, dito ka lang ilalagay. Rather dito na lang. T sub B is equal to what? Anong factor natin or multiplier sa T? That will be what? Coming from force triangle. Anong ratio? Is equal to T vertical? Ano yan? Go ahead.
Sir, yung sa ano lang po, yung sa square root po. Ano po 'yun? Tawag doon, square root of 34 po.
Square root of 34. Mali yung dinig ko. Okay. Square root of 34. Okay, buti na address to. No? Kasi mag-iiba yung result natin dyan. Okay, class, ayos natin itong triangle. Okay, so square root of 34. Okay. Thank you for addressing that. No? So, now, for T sub B, ano yung ating factor here for T? Go ahead. That is what? Plus. Ano yung
Sir,
factor
yung ano po ba? T sub V over hypotenuse po ba?
Oo, tama. So, gagamitin mo itong slope triangle here. T sub B, di ba, alam, parang ratio and proportioning lang. Kumbaga yung component nitong T vertically is just what? Using the factor here, using slope triangle, that will be what? Ano yung vertical component ng slope triangle? That will be what? 3, right? Go ahead. Sino yung gusto mong participate?
3 over square root of 34 po.
Oh, tama. So, multiplied by T. So, and that's already the component T sub B. Then, how about T sub H? How about T sub H? Plus, using this slope triangle. That will be, go ahead.
5 over square root of 34.
Okay, tama. So, ito yung multiplier natin sa T. So, meaning, naka-component na yan ng yung value ng T. Okay, with this particular factor here using slope triangle. Okay, so now let's go straight to the computation. No? So, para makompute natin yung value ng T here or the tension acting at the cable. And later on, makompute natin kung ano yung magnitude ng stress, no, with a given area ng cable. So, class, can we solve this value of T na using equation of equilibrium without computing the reaction here? Anyone? Can we solve? Can we solve right away the value of T without computing the reaction at point C here, itong hinge? Anyone? Sige nga, sinong maruli sa statics din? Can we solve that? Anyone, can we solve? We can solve, di ba? Walang makasasan loob ba? If we do summation moment about point C, di ba, hinge naman yan. This is free to rotate. No? But this is not permitting vertical and horizontal movement. So, pwede rotate. So, summation moment is 0. Diba? So, summation moment about C, diba? You can get already T, right? So, summation moment about point C at the support. Positive again, clockwise direction. Now, class, summation moment about C, what is the moment effect of 600 pounds weight here? It will, ang direction ng rotation about point C. Clockwise or counterclockwise? Yes. Is this clockwise or counterclockwise?
Clockwise po, sir.
About point C. Nakikita na ito. Take note, class, pag sinabi natin clockwise, yun yung direction ng ikot ng clock. Di ba? Ang direction ng ikot ng clock is, di ba, gumaganon. Okay? Tignan nyo yung relay nyo, di ba? Ang ikot pa ganun. Pag clockwise, pag counterclockwise, sabihin, kabilang ikot or opposite the direction. So, anong ikot nito?
Counterclockwise.
Okay, so counterclockwise siya. Ang assumption natin ay positive clockwise. So, meaning positive or negative ang moment effect.
Negative po.
Okay, negative 6,000. What's our moment arm? From point C. We are taking moment about C. Ano yung moment arm natin?
Times 5 po.
Okay, tama. And now, what else? Ito, meron tayong tension here, no? So, that will be now, positive or negative for effect ng tension here?
Positive po.
Positive, di ba? Kasi kung imagine mo itong tension, will rotate clockwise, right? So, I think kuha nyo na yan. Ulit, review lang naman to. So, T times ilan ng moment arm? 40. What's our moment arm? 5, right?
5 po.
5 pa rin, di ba? 5 naman to. Then, now how about, di ba we're taking moment about point C? Meron bang moment effect itong horizontal component nitong inclined force here? Meron bang moment effect?
Wala po.
Wala. So we will not be considering this one kasi this will pass through point C. No? So T sub B lang ang meron. Okay, so now class, positive or negative for the moment effect of T sub B about point C? Positive, negative. About point C. Ito na, tinuturo ko na yung rotation. No? Positive or negative? Class. This is still positive, right? So T sub B. Now, give me the moment arm. Ilan yung moment arm? Ng T sub B.
3 po.
From point C.
10 po.
10. Okay, di ba? 10 yan. So, yun yung moment arm. Then, we all know T sub B is what? 3 out of square root of 34 ng T. So, okay, don't forget to equate this one to 0. applying equilibrium condition, that is negative 6,000 times 5 plus 5D. Ang T sub B is what? Plus 10 times, ang T sub B is 3 divided by square root of 34 ang value ng P. Then equal to 0. Now, plus, you can do directly shift solve here, no? This is 5T rather, by the way. 5T. Now, you can directly shift solve, no? Put nyo lang x yan, x. Okay, but I wanted it na i-simplify ito. So, 5 plus. Guys, you can do shift solve already, no? I will be putting this one into a simplified term. Then, tingnan natin ng parehas. Okay, so this is bibigay pala na. Sige nga, kanilibin na lang directly. Solution na rin naman yan. No? Pero ang lumalabas sa akin ay 10.145T. So, of course, transpose ko to is equal to 6,000 times 5. That will give you 30,000. And of course, 10.145 divided by 10.145, and that's already the value of the tension rate. Okay ba? Guys, anong sagot niya? Ginamit yung shift solve. Can you give me? What's your answer? Plus 2,000? Are you getting 2,000? 957?
7.13 po.
Wait, 13 or 12? 13?
Opo, sa shift solve po.
Okay,
13.
so 13 na lang. 13,2957.13. This is pounds, right? Now, we can already get the stress. Therefore, stress is equal to P all over area. And take note, the force acting at the cable is the tension force. No? It will be 2,957.13 pounds all over. Ano yung area given kanina? This is 0.6. Given pala yung diameter. No? So, area is what? Pi over 4 d squared. So, that will be, okay, let me zoom this one again. Oops. Pi is pi all over 4 times 0.60 inches square na. Now, can you give me the stress in terms of pounds per square inches? Area ng circle yan. Take note, ang cable ay circle, no? Ang cross section. So, given diameter pi all over 4 d squared. Can you give me the value already? What's your answer? Class. Participate para matapos agad natin, no? Okay, I want a participation. So, somehow I know you're solving also. Guys, anong answer? Ano yung value ng stress here? Anyone? Okay lang kahit mali yung sagot or what? 10,000? Parehas ba?
Opo, sir. 458.7.
70 or 60? 70 na. Tama ba? Or 68? Well, similar lang naman halos ano. That's considerable na. Okay, ito na lang ilalagay ko. Pero at least parehas tayo na 1 So that's pounds per square inches. Now class, ano tong pounds per square inches? Ano to? PSI, di ba? So PSI yan also. In abbreviation. Okay. So, any final answer here. Okay, for this problem. Okay, so let's go next to an example para ma-apply ito ng yung mga problems here. No? So for problem number 4, guys, are you with me with problem number 4?
Yes po.
Okay, so a rod is composed of an aluminum section rigidly attached between steel and bronze section, as shown in figure P-107. Axial loads, they are applied at the position indicated. Now, if P is equal to 3,000 pounds and the cross-sectional area of the rod is 0.5 inches squared, so meaning pare-pares lang yan, kung nagkatagan, pare-pares lang yan ang cross-sectional area, 0.5 inches squared. And then now, determine the stress in each section. And take note, we have three materials here. This is aluminum between steel and bronze, okay? And given the location of the um, forces P here, and a single force P equates to 3,000 pounds. And take note class, di ba? 1,000 pounds is equal to 1 kips, right? So meaning 3,000 pounds is equal to 3 kips, right? In terms of kips or K. So 3 kips or 3K. So now, referring to this figure, no, how can we solve on each stresses, di ba? On each section. Of course, we will be doing what? Cutting up section para makita natin yung force acting internally on the member. Diba? So, let's say, unahin natin yung sa steel. Diba? So, if we will be cutting this one and consider the left portion of the body, then we can draw a free body diagram. So, let's say ito yung cutting section ko here. Let's say, cutting section AA or A na lang later dyan. So, FBD or free body diagram. A left section. So kung left section kino-consider ko dito, ano makikita niyo diyan, 'di ba? Ito 'yon. Will be steel pa rin, 'di ba? So in the cutting section here A. Then this is a steel section. Then what you are seeing is what? External force of 4P. No? And 4P is what? 4 times 3. That would be what? 12 kips, right? So 4P here, 12 kips. Natin 12 kips na lang, 12K. And now, class, kung kinat ka tong section na to, meaning may internal force acting on this member. Now, ano magiging internal force here? No, anong direction and anong magnitude? Class. Anyone? Diba, this is for the steel section, kinat natin yan. So let's say, i-assign ka to as yung internal force acting on this section here, this cutting section is P sub S. No? We do summation force, horizontal, is equal to 0, positive going to the right rather, no? P sub S minus 12 kips is equal to 0, and simply P sub S is equal to 12 kips, right? Right? No. So, yun yung internal force acting of this member. Yung pilat natin yan. Summation force horizontal, again, this is equilibrium equation. Or simply, kung ma-advance na kayo, di ba? Kung ilan yung, di ba, action-reaction, kung 12 kips yan, siyempre mag-reacto internally as 12 kips also. Pero yun yung P sub S, which is 12 kips. Okay? And right here, 12 kips. Now, we can already compute for the stress acting at the steel, di ba? Stress is equal to P all over area. And that will be what? Tagayin natin to steel, di ba? P sub S na lang yan. That will be P, the force acting at the steel section here with our pre-body diagram consideration here is P sub S, which is 12 kips. So that will be, yun na lang, P sub S to. That is 12 kips divided by the given area of 0.5 square inches. Yes, can you give me the value? 12 divided by 0.5. Go ahead.
Sir, di ba po kukunin pa yung area?
Given siya, yung area.
Ay, sorry nga po.
The cross-sectional area. Ano na siya? Hindi siya diameter. No? Akala mo siguro diameter. Tama ba? Okay. So, take note class. No? Baka malito kayo. This is an area already. Yan minsan nagiging mali namin sa quizzes. No? Akala namin area na or diameter. So, dapat malinaw kayo dyan. may akala ko diameter lang. Or area na pala. Okay, so ilan to? Class. This is what?
24.
24 po.
Okay, so meaning 24 kips per inches square yung stress na nararamdaman ng seat here. No? So, this is also in KSI. No? Now, of course, sa steel pa lang yan. So, how about sa aluminum section? So, if we do a passing plane here, or cutting plane, let's say B yan, then we will be considering. Now, class, disregard this cutting plane A here. Ang i-consider lang natin itong cutting plane B. So, let me write it here, FBD. For cutting plane B, no? Left section. Okay, so meaning kung kanat ko yan, kung consider ko yung left section, ano makikita ko? Siyempre, buo yung steel section here. Then, a portion of aluminum to represent na nag-cut tayo ng section here at point B. And then, ano makikita nyo? External force. 4P pa lang din naman, no? Still 4P pa lang yung external force na kasama dyan. If we are to consider the left portion of the free body diagram, cutting plane at P. So this is still 4 kips, 4P or simply 12 kips pa rin. No? And of course, kung nag-produce tayo ng cutting plane, di ba, tinaga natin yan, ano makikita mo sa loob, yung internal forces or reaction, okay, by the body that will be what? Siyempre, going in direction yan, going to the left, action-reaction, going to the right yan. Ang hindi lang alam natin is yung magnitude. But basically, summation force horizontal, it will give you also 12 kips. No? So, i-write na lang natin itong P sub. This is aluminum. So, kung aluminum yan, let's say P sub A na lang. So, summation force horizontal also. Zero positive going to the right. Para masayang na lang tayo na equilibrium equation. So, that will be negative 12 kips plus P sub A is equal to 0. Meaning P sub A is equal to 12 kips. And as you can see, positive yung magnitude. Ibig sabihin tama yung assumption natin ng direction. Okay? So, stress, no? Acting at member or at a section, no? Along the aluminum. The length of the aluminum bar, that will be sigma sub A na lang, no? And P sub A all over the area. And again, class, uniform naman yung cross-sectional area. So that will be, again, 12 kips divided by still 0.5 square inches yan. And then, walang yan class. So 12 divided by 0.5, still, diba parehas lang naman, 24 kips per inches square. And that's still KSI in abbreviation. Okay, so now lastly, for the bronze section here, kung makikita nyo class, uniform naman yung area. That's why kahit saan tayo mag-cutting in any length of the bronze section, di ba, or aluminum, iisa lang yung stress, di ba, uniform dahil nga iisa lang yung area all throughout the length. Okay, so let's say ang cutting point ko here is dito, no? Okay, so kasi kung i-cut natin tong cutting point here, itong point C, somewhere na mapuputol yung arrowhead ng force, ano mangyayari na? You would still consider the force P here if you consider the left portion. Kasi ang kinoconsider naman natin dyan, that we zoom this in, ang kinoconsider natin, let's say dito yung cutting point. No, kahit naputol mo yung arrowhead, ang kinoconsider natin yung tail ng vector na to or this force. So meaning galing yan sa junction between aluminum and bronze. So meaning between the span or length ng bronze, this force P would still act. No? So, drawing natin into a free body diagram. So, FBD point C, cutting plane C at the left section. So that will be what? Of course, buo yung steel, then buo yung aluminum, then dito tayo nag-cut sa somewhere in a portion ng bronze, right? This is cutting plane C. And then let me write it here: steel, aluminum, and bronze. Okay, so anong makikita nyo dyan, di ba? Ibahin ko naman ang kulay para makikita nyo. The external applied forces is still 1. Ito ay 12 kips pa rin, di ba? 4P. So 4 times C, 12 kips. And we have force acting at the junction between the aluminum and the bronze, right? So ilan yun, class? Ilan yun? Yung force acting at the junction between bronze and aluminum. Ilan? Class. Can you see this one? This is P, right? So, ilagay natin yan. Yung force na yan acting at the junction ng bronze and aluminum. So, that is what? Ilagay lang dito, this is P, right? And a single value of P represents what? 3 kips of magnitude. So, this will be 3 kips, right? This particular force, 3 kips yan. And then, now let's represent the internal force acting at this cross-section in the cutting plane. No? So, kung mapapansin nyo class, 12 keeps going to the left, then 3 keeps going to the right. So, meaning may sobra pa rin na 9 keeps going to the left. So, you can just simply write here, no, na ang direction is going to the right. And also, the value is 9 keeps. Pero, just do the equilibrium equation para formal yung solution. So, that will be P sub bronze, no? P sub B, or the bronze section. Okay, so that will be summation force horizontal is equal to 0. Positive going to the right, that will be P sub B minus 12 kips going to the right plus 3 kips is equal to 0. And kagaya nung nabalik ko kanina, di ba? Arithmetic lang naman, still 9 kips yan. Ang internal force acting at this section is 9 kips per right. Okay? So again, internal yan to the body. So 9 kips. Now, stress acting at the bronze will be P sub B all over area. So 9 kips divided by area of 0.5 inches square. And the stress experienced at the section in this particular material of bronze is what? Can you give me? Ilan to? Ilan yung
18
class?
po.
So 18. 18 kips per inch square. So KSI na lang. Shortcut ko na. So here are the answers. Right? So these are the stresses in each section of the bar here. Now class, ito pala lang, take note. Okay, kung makikita nyo dito, meron tayong graph here. This is what we called the axial force diagram. Now, ang assumption ng sign here, kung bakit positive yan, is that, I forgot to mention pala na, let me go back here. We have the unit convention here, na aside from from the units kung pa nandun sa atin kanina yung units ng force, area, and stresses. For the convention naman, anong sign convention? Positive for tension and negative for compression. Okay, so let me go back here. So for the axial force diagram, kung makikita ninyo, class referring to this FPD here, no? Itong P sub S, tension yun or compression? Class, tension or compression? Okay, this is the section here. This is pulling away. Tension or compression?
Tension.
Tension, right? Di ba? Tama, di ba? So, di ba kapag sa thrust din at from the joint, kung pulling away yan, tension, pag going into the joint, this example, this is the area or section, the current section, going away to the section, this is tension, going into the section, this is compression. So, let's give you 12 kips. So, meaning, uniform naman yan all throughout the length of the steel, 12 kips yan, that's why 12 yan. So, from 0, starting on the left, so, positive, from 0 yan, di ba? Going up, positive 12 kips, then going to this junction, 12 kips pa rin yan, and then, pag nag-continue kayo, no, itong P sub A. Si P sub A ba with a magnitude of 12 kips here, 20 yes, 12 kips na yung value ng axial force. Tension ba yun or compression? Plus. Tension or compression?
Tension.
So tension, still 12 pips yan positive. So itutuloy mo lang yung diagram here going to the right. Prior to this junction, no, na may application na ng 3 kips, no, going to the right also. Now class, pagdating dito, no, sa pangatlong free body diagram, diba, na-compute natin um, na 9 kips na lang yung magnitude. No? Why is that so? Kasi pag kinat mo yan dito on the section, ano mangyayari? Kung pinakonsider mo rin 3 kips, it will give a compression force here, no, at the section. Pero in general, yung total result na vis-a-vis has a value of 9 kips. So meaning, kung based on the actual force diagram, kung 9 kips yan, nag-drop down ng 3 kips here, no, para makuha tong 9 kips. So going here. Okay? So yun yung representation ng axial force diagram. Okay? But typically, on this axial force diagram, hindi naman tayo masyadong concerned on this one kasi we can just do tawag dito, cross-sectional analysis, or we do methods of section, then kinukumpit natin kung ano yung mga stresses acting at those section. Okay? So yun lang naman yun. Now, let's go to problem number 5 and 6 and also 10. So I think kaya to bago mag-11. Okay? Thus, I need your quick participation para ma-hit natin to na matapos ng 11. No? So, press your calculator. I want participation. So, problem number 5. An aluminum rod is rigidly attached between a steel rod and a bronze as shown in figure 108. Now, axial loads are applied at the position indicated. Okay, let me zoom this in more. Find the maximum value of P that will not exceed a stress in steel of 140 megapascal and in aluminum 90 megapascal or in bronze of 100 megapascal. So again, this is the allowable stress or the limiting stress or the working stress, no, for this material, for the bar or rod. No? So ang arrangement natin class is that ito, steel, no? Siya yung naka-attach here on the wall. Then aluminum sa gitna, then bronze. Given yung area, cross-sectional area, 500 millimeter square, 400 millimeter square, and 200 millimeter square for the bronze. Then again, this forces P here represents the external forces applied to the rod. Okay, so now how can we compute, no, kung ano yung maximum value of P that this rod can handle or can handle or can experience without exceeding these stresses. No? So again, we need a free body diagram. So let's say we produce a cutting section here. No? Let's say this is point for the bronze. No? Let's say A na lang to. B, cutting section C. No? So, okay. Correct natin. No? B na lang to. Then aluminum A, then S. So, this is the cutting section. Free body diagram. B, right section. Okay, so ano makikita nyo with the right section? That will be what? Ito yan, di ba? Cutting section B, then this is for the bronze. Then this is what? 2P. Right? Ito yung externally applied load. This is 2P. Now, class, kahit hindi na tayo summation force horizontal, applying equation of equilibrium, we all know already that the internal force acting on this section of the bronze, no, sabi na lang ilalagay ko, is equal to also 2P, right? So, action, reaction lang, yan, and then 2P yan. Okay? Now, class, my question is this a compression here or tension for P sub B? Class.
Compression po.
Okay, so P sub B is equal to 2P in compression. No? So, compression portion. Now, applying stress formula here, no? Given naman yung area ng bronze here, 200 millimeter square. No? So, area is 200 millimeter square. And given stress is, allowable stress is what? It should not exceed for the bronze. This is 100 megapascal. MPa. So now class, okay, ang formula is stress is equal to P all over area, but also P is equals to stress times area. So P, anong pin natin here? That will be P sub B. No? Okay, so that will be 2P is equal to stress 100 megapascal, which is 100 Newton per millimeter square for the bronze and yung allowable stress. And then the area given here is, rather, ito pala no, for the bronze, 200 millimeter square. Okay, so 200 millimeter square, this will cancel out. Okay, 2P is equal to, it will be 100 times 200 divided by 2. This is in Newton. Anong value ng P here, class? Can you give me? 100 times 200. 10,000. No? So this is 10,000 Newton. So meaning, yan yung kayang dalhin ng bronze bar here. No? Given allowable stress of 100 megapascal. Okay, so 100 Newton. Lagyan natin P sub B to represent for the bronze. Now for FBD naman, no, on the cutting section of at point A here, no, for FBDA, then again right section for consideration. So this is the cutting section, no, not the subsection. Considering the right portion here, that will be, of course, this is the aluminum. Then bronze, buo yung bronze, diba? Hindi ka naman tayo nag-produce ng cutting plane. And ano nakikita natin dyan? Merong 2P kanina, externally applied load 2P, and externally applied load at the junction of bronze and aluminum. This is P, right? So, and then, of course, class, kung 2P ang going to the left, then may going to the right. Ano yung resultant nito? Ilan yan? Meron tayong sobrang 1P going to the left. So, meaning kung going to the left yan, sobrang ng 1P, I can assume that the direction of the internal force acting at this section, no, is what? Going to the right. So, this is P sub A na lang for the aluminum. So, in this case, para di kayo malito, summation force na kayo, horizontal is equal to 0. Positive going to the right. Okay, P sub A. But obviously, 1P yung value niya. Kasi ang resultant itong dalawang to, 1P going to the left, so meaning P sub A is 1P going to the right. Pero yun nga. Okay, P sub A plus P minus 2P is equal to 0. Then P sub A is equal to simply P minus 2P, that's negative P, transpose to the other side, that's positive P. Okay, so PA is equal to P, or simply 1P. Now, okay, applying the stress formula, again, P sub A is equals to stress times area. Okay, and P sub A has a magnitude of 1P, which is equal to stress, no, allowable stress for, take note, this is aluminum. Okay, on this cutting section. Then this is aluminum and steel lang sa isa. So, ang aluminum, no, ang allowable stress is, ilan to? 90 megapascal. So that will be 90 Newton per millimeter square times the area, which is given here, area for the aluminum is 400 millimeter square. So 400 millimeter square. So cancel yung millimeter square here. Anong value here ng P? This is 36,000?
36,000.
Okay. 36,000. Okay, 36,000 Newton. Okay, this is P sub A. Now, continue natin yung pagsuot here. So, okay, ito na lang class. Nakita naman dito. So, okay, I think this piece will work. So, FBD at the cutting plane S here no, for the steel section. So, considering all, again the right section or portion. Now, that will be what? Of course, buo yung um, steel, yung length ng steel, and then there's aluminum. Then also, ito na yung sa portion ng steel. Right, the cutting section here. Now, of course, lagyan natin yung mga externally applied load, which is 2P. Then this is P. Okay, so borin na natin to para P na lang ilagay natin. Okay, so this is P. No? Again, this is an externally applied load P. Yan na lang. No? And then, what else? Meron pa tayo dito at the junction between steel and aluminum. Meron pa yung 4P. Okay? So, 4P yan. 4P, then P, and then 2P. Okay? Now, of course, when we do the cutting section, makikita natin yung internal force acting at this particular section. Then that will meaning so ang resultant is slightly going to the left, so ang internal force here no will react no going opposite and with the same magnitude. So kasi ko dito P sub S equal ko na dito 5P na lang ito no. Okay, so sinargat ko na pero sige na ito na natin yung solution. Summation force horizontally equals 0, positive going to the right. That's P sub S positive minus 4P A plus P minus 2P. So it's equal to 0. Negative 4 minus 2, negative 6 plus 1. That's negative 5 as opposed to the right. That will give you 5P. Go ahead, my question. Do you have a question? We, what's that? Okay, participation, I guess. So now class, okay, let's continue. So again, formula is what? P is equals to stress times area, or force is equals to stress times area. Okay, so our P here is P sub S, so that will be 5P is equal to allowable stress for the steel is 140 megapascal, so 140 Newton per millimeter square times the area of ilang air natin for steel. This is 500. No? 500 millimeter square. Okay, so let's cancel out this one. And then, ilan to class? Can you give me?
14,000.
14,000. Okay, so 14,000 Newton. Okay, so P sub S. Now, class, yan yung mga computed value ng P. The question here is that, what is the maximum value of P that will not exceed the stress in steel, bronze, and aluminum? So, ano yung PPD nyo din, class? Ano yung P na i-recommend nyo in order na hindi may exceed yung stresses ng lahat ng member ng bar or rod? Alin dyan? Is it 10,000, 36,000, or 14,000? Anyone? Anyone? Okay, I have to answer para dahil we are running out of time. So, you will be choosing the smallest value here. Okay, let's say nirecommend mo sa kliyente, ano ba yung maximum allowed value ng P, no, in order na walang magkakaroon ng failure or walang mag-exceed sa limiting stresses sa material. So you will be recommending 10,000. Why is that so? Kasi kung i-recommend mo yung 36,000, di ba? Kung ang kaya lang ng bronze ay 10,000, edi magpipail yung bronze. Similarly with sa steel, no? Kasi kung 36,000 na-recommend mo, edi magpipail agad sa steel. Whereas kung ang recommend mo naman ay 14,000, yung maximum allowable value ng P, then um, definitely itong aluminum, hindi yan magpe-fail. But the bronze material here or the rod will fail kasi nga 14,000 lang yung kaya nun or capacity. Right? So meaning, therefore, the maximum value slash allowable P should be 10,000 Newton. Okay, in order not to exceed the allowable stresses in all the material. Okay, so ganyan. Now let's continue more here. Okay, I'm planning na magkaroon ng last example na you can just apply using our okay, with the assignment that I will be giving to you. No? So that will be the trust. No? Um, Yung trust na lang. No? Then, isolve na lang natin to on the FTF class next meeting. Okay? Since we are running out of time. Okay? By the way, class, mga ilang hours yung travel time nyo? Okay, can I ask? Ilang hours yung travel time nyo going to school? Guys, mga ilang hours around class?
1.5 hour po.
Okay, so yung 2 hours would be saved. Sige, that's problem na lang to. Okay, so sige. That's problem number 10. Okay, so for problem number 10, okay, find the stresses in members BC, BD, and CF for the truss shown in figure P-113. Indicate the tension or compression. Okay, the cross-sectional area of each member is 1,600 millimeter. Now, as given na yung cross-sectional area ng member. So, ang kailangan natin i-compute is the force acting at the member of the being asked here, no? BC, BD, and CF. And kung nakabit na yun, simply stress is equal to P all over area and that's it. May area ka naman. So, kailangan natin masolve ito. Okay? So, given this stress, no? We can compute this one without computing the reactions. No? We can do a method of section here, then we consider the left portion of this section. So, let's say the cutting point here, the cutting plane is A prime. So, FBD A prime. Okay, considering the left section. And what you will be seeing is what? No, pag nagkaroon tayo ng cutting section here, so we will represent the internal forces acting on the member. That's, of course, this is BD, right? Ito yung hinahanap. Then, here also, looking at natin yan, no? Kasama yan sa cutting section here, of course, you will have to represent the internal force acting at member CD. And similarly, for CF, no? Dinaanan din yan ang cutting section. Then, makikita nyo yan yung, makikita nyo is that what? You will need to represent an internal force acting at member CF on this direction. Now, class, again, on the methods of section, itong mga direction na to ay assumption ko lang. So, I assume this one, lahat intention, no? This is pulling away from the joint. Now, kapag may lumabas na negative sa ating solution, ng magnitude, meaning that's the opposite. Okay? So, kung tension ng assumption, then nag-negative sa computation, then that should be compression. Okay? So, let's go straight here sa computation. Now, class, in the method of section, no, you can do moment summation at any point. No? You can do in each joint, since spin naman yan, walang rotation or zero moment, so you can apply summation moment. So if I will be applying summation moment about point D, magpapass through itong member BD, diba? Magpapass through din itong member CD. So I can already compute for member CF, right? So, but take note guys, member CF here is what? This is, tawag dito, this is diagonally oriented. So meaning we need to have the um, slope triangle so that we can get the component here, no? Horizontally and vertically. So, okay, similarly with member BD, 3, 4, 5 yan, yung slope triangle, then 4, 4, and 4 is square root of 2 for member CF. Saan nanggaling yung class? Diba? Ito yung member CF. Okay, ang dimension is 4, then 4. So, slope triangle, 4 and 4, and then 4 squared plus 4 squared is square root of that. That's 4 square root of 2. And on this first member, this is BD. Okay, um, ang slope triangle will be of course 3. Then dimension is 4 horizontally. So 3, 4, 5 slope triangle. So now again, member BD is coming from joint B and member CF is coming from joint C. Okay, that's why nagagaling din yung mga component. Now, taking summation moment here, no, about point D. Okay, summation moment about point D is equal to 0, positive going clockwise. Now, as if I take summation moment about point D, diba? Ang forces available na may effect in terms of moment effect, that will be 60, 90, and CF. So, unahin natin 60. So, 60 will rotate counterclockwise. No? That's negative 60 times, plus anong moment arm going to point D for 60 loading. Ilan yun? Moment arm at point D. Summation moment about point D. So, ang moment effect ng 60 ilan? Plus. Moment arm of point D. Anyone? Plus. Moment arm.
7, sir.
7. Tama, 7, no? Sige, class, let's just follow my this discussion here, no? Para mabilis. Okay, so that will be negative 60 times 7. Then for 90, that will be negative 90 times, of course, from point D, the moment arm of 90 kilonewton is 4. Then for member CF class, okay, meron yung component horizontally and vertically. But as you can see, yung horizontal component ng CF will pass through point D. So wala yung effect. So what are we up to is the vertical component of CF. And the vertical component of CF represents what? 4 divided by 4 is square root of 2 times CF. So again, ito yung direction ng component here. So still counterclockwise. So that would be negative 4 all over 4 is square root of 2 times CF. Again, class, take note, I mark it here. This is C vertical, CF vertical. No? So, times the moment arm is same pa rin naman, 4 meters yan. Okay, and what else? May involved po ba na forces? Wala naman. So, is equal to 0. Now, let's compute for the force acting at member CF. So, negative 60 times 7 minus 90 times 4 minus 4 divided by 4 is square root of 2 times x times 4 times 6 number CF here is compute siya is negative 275.772. This is in kilonewton. So meaning that nag-negative yan. So ang tamang direction yan should be in the opposite. So that should be in compression. So meaning CF is equal to 275.772 kilonewton compression. Okay, now to get the stress formula here, siyempre, force over area, P all over A. So that will be what? 275.772 772 kilonewton divided by the given area. Pare-parehas naman silang 1,600 no, millimeter. Okay, so go ahead, what's your question?
Sir, ask ko lang po, bakit po hindi sinama yung sa B? Yung mga
Um,
unknowns po na nandoon.
okay, hindi siya sinama dahil again, itong member BD, no, this will pass through point D. So meaning wala siyang moment effect. No? Hindi mo siya i-consider on this case kasi nga kung kinonsider mo itong original force member BD for going to point D, then wala yung moment effect. No? So you have to disregard this component. Okay?
Kahit po yung horizontal, sir.
Yes, wala siyang kumbaga, buburin ko muna ng para hindi ka malito. Okay. So, class, imagine, wala pa siya, originally wala pa siyang component. No? Kumbaga, takpan mo yan, wala yan din. Pag nag-moment at point D, lahat ng forces here, BD and CD will pass through here. So, meaning, ang may moment effect lang would be itong CF vertical, no? And even C horizontal wala. Okay, kasi BD represents already what? The resultant of those components. So, kumbaga, originally, wala naman talaga dapat yun. Inaano lang natin siya, component kapag kailangan natin siyang i-compute using summation moment. Okay? At a certain point. Kuha ba yan?
Okay po.
Okay. So, okay, ibalik ko class na para so, right. So, this is 772 times 10 raised to 3 Newton na, 10 times 10 raised to 3, para Newton yan, and then ang area kasi is in millimeter square, that's 16 millimeter square. So, stress will be 1,000. So, times 10 raised to 3 divided by 16. It gives me 172.36 megapascal or Newton millimeter square unit. And take note as this is compression, so meaning compressive stress. Okay, so now let's continue. Okay, so we can also take a moment about point C. So we can eliminate the moment effect of member CD here, or first acting at member CD and also CF. So in that case, so, wala ring moment effect tong 90. Ang meron lang would be itong member BD. So in this case, pwede na natin siyang i-take yung component ng BD now when we are about to take moment about C. Okay, so summation moment about point C. Positive clockwise once again. So about point C, still itong effect here ng 60 kilonewton is counterclockwise. So that's negative 60 times 3 meters going to C. So 3 and moment about point C. Okay, wala na moment effect ng mga to. Okay, is forces since it passed through point C. So itong member, BD na lang yung may moment effect. Now, on this particular take, no, has component BD horizontal and BD vertical. So, walang moment effect yung BD vertical since it will pass through also point C. So, BD horizontal lang. And as you can see, BD horizontal is equal to 4 out of 5 no, using slope triangle here for yung horizontal component ng slope triangle. So, 4 out of 5. The hypotenuse is 5 and then multiplied by BD. So, now that will be the direction of BD horizontal is clockwise, so that's positive. 4 out of 5. Okay. 4 out of 5 BD. And again, take note, this is BD horizontal. So, multiplying this one on the moment arm. Ang moment arm natin, class, this is 3 meters, right? About point C, perpendicular distance. Okay. So, 3 meters. Then, wala na. It equates to 0. then that's already the force acting at member BD. Okay, so negative 60 times 3 plus 4 out of 5 alpha x times 3. So BD is 75 um, kilonewton. Then therefore, the stress is equal to force over area, or P all over area. And will be 75 times 10 raised to 3 all over the given area upon 6 um, millimeter square. Okay, this is Newton, then it will give me a megapascal unit. So 75 times 10 raised to 3 divided on 6. That is 46.88 megapascal. And take note class, nag-positive yung ating value kanina. So meaning this is in tension since ang assumption natin ay tension. Remember BD. So this is tensile stress. So lagyan mo ng abbreviation here or subscript sa baba. This is member CF. No? And this is member BD. So yun yung mga answer. So that's problem na. That's member na class. Don't worry. No? So okay, last problem. Okay, or rather last member na. So the last member is member BC. So we can solve that using methods of what? Joint. Now, considering joint C here. So considering joint C, so FBD at joint C. Okay, so FBD at joint C. Ayan. Okay, FBD at joint C. Okay, yung FBD at joint C will be okay, at joint C. I'll later zoom this in. No? At joint C, so member BC yan. Okay. Then, ano nakita natin dyan? Member CD. Hindi ko natin kinumpute. So, assuming member CD is going tension and then member AC. Then, may 90 kilonewton downward. Now, class, itong member CF, we can apply already through the correct direction. No? CF is in compression. No? So, we can already write it in compression with the magnitude of 275.772 kilonewton. Okay? And again, still 4 square root of 2 pa rin naman yung slope niya. So, let's zoom this in. No? Since ito na lang naman yung compute. So 4 square root of 2. Then we can already get the value of member BC here. Summation force vertical is equal to 0. Positive going upward. So ano meron dyan? Member BC, the unknown, minus 90 kilonewton downward. And for this force, no? Going upward yung vertical component yan, that will be plus 275.772 times, of course, to get the component, that should be what? Ang multiplier natin is 4 divided by 4 is square root of 2. Right? So, yeah, and then let's equate this one to 0 to get the actual value or to state equilibrium condition. So BC is equal to here compute plus 275.772 times 4 divided by 4 square root of 2. So it gives me value of negative 105 point negative 105 kilonewton. So meaning BC, kung nag-negative yan, ang assumption natin is intention, BC is 105 kilonewton in compression. So now, therefore, stress acting at member BC is equal to force over area equal to 105 times 10 raised to 3 Newton divided by 1,600 millimeters squared. Okay? Now, take note guys kung magkakaiba yung section ng member, di iba-iba yung area that will be used here. Pero pare-parehas naman yung sectional area. So, kumparin yan. So, 105 times 10 raised to 3 divide 16. Okay? So, it will be 65.6 to 63 megapascal. And this is a compressive force. Or compressive stress tali. Okay, so this is the last problem, but I have a conclusion. Kung mapapansin nyo class, ang pinakamataas na nakakaramdam ng stress is member CF. Why is that so? Kung mapapansin nyo dito, nasa ating structure, this is member CF, and this is the support. No? Okay, kung i-analyze nyo yung mechanism ng load na to, di ba? It will what? It almost what? Produce, will what? Will bend, no? Or will rotate on this motion, and ano nangyayari? Kung i-analyze nyo yan, tutukod halos lahat yung bigat dyan, yung weight, no? This loading, and this is clearly subjected to compression. And kaya kung mapapansin nyo sobrang laki nung binubuhat niya kasi the forces that is being transferred on other member ay salong-salong itong members here. Okay? So, class, this conclude our meeting, and also class, take note kung ito pala, kung i-vertical mo naman to, similar application lang naman, di ba? Kung itataya mo siya, this bar, you would still what? Produce cutting section, no? Para ma-compute yung mga forces internally, and later on compute the stresses. And class, I want to show you here, this is on your modeling canvas. You can check the other solved problems here. No? Okay, so para ma-refer kayo yan. And check. So okay, we are done here by the way class. Just check the canvas on your assignment. No? That will be submitted next week for FEB class. Okay, go ahead. Do you have question or an attendance?
Sir, yung ano po, yung sinolve po natin, i-upload niyo po yan sa Canvas.
Itong sinulog natin actually ay bibigay ko siya as meeting notes, no? Para ma-review nyo din. Bigyan ko kayo ng copy. Itong nasa page, no? In PDF na siya. Okay, sino pa yung humabol sa attendance? Doon sa iba, kayo rin magbiyahe, no? I think si na abroad lang. Si Liagas. Sino pa? Liagas, sino yun? Libres. Sige, may iwan na lang yung mga mag-attendance. Pero doon sa iba, you can travel already. Okay, that's Libres, Liagas. I cannot see ito. Libres and Liagas. And Buena Obra. Okay, who else? Dun sa mga nag-participate, don't worry, I'll check your attendance later. Cuevas is also present. Check ko na.
Gante po, sir.
Participant ka ata, so I can acknowledge your attendance. Eh. Since nandito ka na rin, check ko na. Don't worry sa mga nag-attend ng tryout, may listahan ako. So I will check your attendance. Kumbaga, isang to clear for an attendance. Okay. Okay, we are done here, class. We can travel already.